Let's look at final exam question number 95 in Everyday Math Demystified 2nd edition. Please refer to page 253. We're talking about voltage, current, and resistance and how they relate. Now, you're going to have to think a little bit in order to solve this problem, because it isn't explicitly worked out anywhere in the book. It's only alluded to how you can do it and how they relate. If you'll go back to page 225 and 226, we describe the units of electrical resistance and how it relates to current and voltage. If we have a current flowing through an electrical component with a resistance that's a certain amount, then we get a certain voltage. If we double the current, we double the voltage. If we cut the current in half, we cut the voltage in half. So here's our situation. And I'm going to draw now what is known as an electrical schematic diagram. But I'll explain what everything means, so you don't get confused if you're not familiar with this. Suppose we have a battery. This is the battery. And this is the bulb. Now we have a certain voltage produced by this battery. The bulb has a certain resistance. That causes a certain current to flow through this circuit. Okay, you following me? There's a certain voltage in the battery, a certain resistance in the bulb, so a certain amount of current flows through here. Now, suppose that we take this battery voltage and cut it to 1/5 of what it was. But the bulb's resistance, let's assume that that stays the same. Just as an aside, in a real-life bulb, the resistance is going to change as we change the voltage across it. But this, we're oversimplifying here, and that's fine. I'm sure that you appreciate that. The bulb's resistance remains constant, so the current that goes through this bulb is going to vary in direct proportion to the battery voltage. If we double the voltage, we double the current. If we cut the battery voltage in half, we cut the current in half. If we cut the battery voltage to 1/5 of what it was, then we cut the current to 1/5 as well. So we reduce the current by a factor of 5. In this question, that is choice C. We cut the battery voltage by a factor of 5. We cut the current through the bulb by a factor of 5. So they vary right along with each other in direct proportion, provided that this bulb has a constant resistance, regardless of the voltage of the battery. So again, choice C is the answer here.